wood column. Column would be in what part of the column? This should be in a flash. We should have this in a flash. Okay, this is a flash question. This is one of the previous question. This should have given you a hint. Or wood columns, that sentence. Right. And 4, 1, bracket 1, and the answer would be correct. Therefore, 9, 17, 4, 1, bracket 1, and your answer would be C. Right, correct. Again, the same thing. We have 4 by 38 is 152. 4 times 38 is 152. 152. Therefore, that's the minimum width, and also the minimum per square has to be at least 140. The answer would be C. An answer just cannot be less than the width of the beam. That doesn't give you a good answer, really. It doesn't say anything. Okay, so let's do another one to 920. Now we have a 1.53 millimeter opening. It's proposed in a 200 millimeter block, 100 masonry, and a 100 brick exterior. The floor is 1.5 above, and we have a load of 7,500 newtons per meter. And the question is the number, the size, lintels. So into 920, and we get that from table in 920 to determine the size. Which table are we looking at? Correct. 925.2, bracket A. A. And No, I keep telling you guys, in plan examination, building inspection, that's a nice job. But then you have exciting days every day, trying to figure out the plans. You have to look for all the lintels and the beam, exterior cladding, all that stuff. So let's see. See. One B. Okay, so we have what? We go to table 925 to A, and because our floor is located less than the width of the opening, no, the opening is 1.53, the floor is 1.5, means that we have to include floor load. The angle, when you go to table 925 to A, answer came out. If you look at the table, it would be B. B based on 1.8. You have to go to the 1.8, and the brick is 100 by 89 by 79. And because we have a 203 wall to go across, and the load is 7,500, which is more than 73. So we go to the next column at 10,950. And we get 152 by 102 by 11. Okay. So that will be our answer. Okay. And 20, here we have a 1.5 meter opening. It's proposed in an exterior wall of 70 millimeters thick masonry veneer over 140 millimeter wood frame. The opening is located 1.5 millimeters below a floor that carries a load of 4,000 newtons per meter. And we're looking for this minimum size of the lintel. And we have the table. Table is where do we find lintels? Which table? A, B, C. And look for the buzzwords. Question. And 25 2. The B, correct? When you write it, Jamari, you don't put a bracket. Okay, it's like B. There's no bracket for the table. I believe it's the center clause. So we got 925 2B. That answer would be correct. So Warren, good choice from table. Go to the table, and we have 70 brick. The opening is 1.5, and in this case, from the question, although it has misleading jargon, it's a masonry veneer. Okay, that's what you're looking for, a veneer. Table 925 to B says maximum allowable spans for lintels supporting masonry veneer. Okay, so there's no excuse for getting the question right because you have words that lead you almost directly to the answer. At 70, we have an opening of 1.5. And the closest thing to 1.5 is 255. So we have to use an 89 by 76 at 6.4. The answer here would be B. Okay. Just a matter of going to the table based on the information here. And then we go to something 920 again. Says according to Division B, Part 9 of the Building Code, steel beams supported on masonry shall have a minimum bearing area not less than What's your code reference? Check again, Warren. Get the question and check again. Jamar, yep. And your reference is Jamar, your reference? Right. Okay, so 920.83. Like I said, the only way you're going to remember this stuff is by a little bit of practice. Practice and make mistakes. The question here says the bearing area and 920.83 bracket 1 as sufficient to carry the supported load. Okay, the other one's are dimensions. This one question has the bearing area. In 21, it says beams supported on masonry must be supported on pilasters where the wall is. In 920. Now, Warren, you can use your reference. Right. Okay. So Warren's reference was 920.84 bracket 1. Eight 8.4 bracket 1. That led you to less than 190. And again, masonry supported on beam supported on masonry. Okay. And supported on pilasters. Right. So then your answer will be D. When you read that, it says beams and columns supported on masonry walls shall be supported on pilasters where the thickness of the masonry wall or white is less than 190. Okay. So that's where the answer will come from. Another one, it says wood beams supported on masonry pilasters shall be provided with the minimum depth of solid masonry not less than D, and the reference this time, Carla, 8. Correct. Right? You see, it's getting better. Trying and reading gets better and better. And then one day you'll be an expert. You just know where to go to find the stuff. All right, so when you read 920.842, it says at least 190. Solid masonry depth. Yep, solid masonry. Again, wood beams. And steel beams. Now, steel beams supported masonry must be supported at each end by a column. They be supported at each end by a wood column of sufficient strength. Must have an even and level bearing of not less than 40. Must have an even and level bearing of not less than 150. D. All right. And your reference comes from reference there. Okay. You got three. Let's see. In my book, three sends me to the table. Since three sends me to the table, okay, that's better. Better. 925 2. If you play with this stuff, this becomes fun. I don't know if you're having fun. I'm having lots of fun. Playing around with stuff keeps you busy. Just to do the things in life that make you feel it's worth living. This is one of the things. You have fun doing that. Covering things. Okay. That 925 to bracket 4 tells me it has minimum 150. Okay. Anything left here? Kind of a long question, and but just for the exercise, but I won't give you that. This is a quick one, and it's a two-story house with a basement, has 190 millimeter exterior masonry walls. The design live load on the second floor is 1.9 kPa and 2.5 on the first floor. The span of the supported joist is 4.9. It says the minimum required width of an exterior strip footing. D. Okay, David, it's a good shot. Why you chose D? Because, right, 915 bracket 1. That would be 915 or 915 bracket 3. Which one? Let me check. 915 If a LIGO force supported by the footing does not exceed 2 point. Yeah, but 3 says where the specified exceeds 2.5, load shall be designed in accordance with part 4. So your answer should be 3 actually. Yep, 3.3. But luckily you don't have to provide a code reference. Imagine what the other students had to go. You got it easier just to find it. Here D because we exceed 2.4. C because C just says it doesn't tell you anything. Just say the specified live load on any floor supported by the footing does not exceed 2.4. It could be a good answer too. Say if I was marking the paper, I'll give you a right answer. Okay. C gets me, tells me exactly I should go to part 4, and the question referred to part 4. But it would not be a problem if I was marking the paper. For the effort, I'll give you. All right. So, any questions? The class didn't get this far. Guys are lucky. Give you the extra half hour. All right. So, any questions so far? So, Monday we'll do a polling. Let's see here. I missed the question here. Census for 7. This one, 7 and 8. Okay, you want 7. Okay, here is 7. Okay, 7 says that consider 31. Okay, we can. Okay, I get there. Okay, it's not under review because I added it. The one about the water to cement ratio. Yep, I will show you that one for finish. In 7, it says that we have is consider 3-story house with a basement. So the stud wall supports the third floor joist. The stud wall and 2 floors are supported on top of a 6-meter high interior load bearing 190 millimeter masonry wall. Okay. And then it says it's an interior load bearing wall, 190 millimeters thick, and that goes, I guess, to the first floor ceiling. All the way up to again. Okay. So we got a footing. And this is an interior wall. So we have a complete block up to first floor ceiling. So here we can say we have this is our basement. Okay. Floor. And so this wall goes to the ceiling, the floor above. Once you erase this whole thing goes anyway. We have a floor here. And the question, so this is 6-meter high, so therefore you probably have 3 meters basement and 3 meters in the floor above. Or double the whole footing width, which is rectangular or square. Okay, so above this we have the stud wall supports 2 floors. Okay, so we have 1 floor. And we have 2 floors supporting double. Oh, is that wrong? So therefore that's why you have to practice, 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 and read the question 100 times. See, even me have problems sometimes. The question says, okay, we have interior wall. Draw the floors first. That will make it a lot easier for me. Here I got the first floor. Okay, and then I have the second floor. And it says I have a 3-story. I have another floor here somewhere. I have 3 floors. And it says I have my 6-meter high interior, 190 meter support on top. The stud wall supports 2 floors. So my stud wall supports 1 floor. It supports 2 floors. 1, 2. Stud wall, 1, 2 floors. third wall. And it says on top of a 6-meter high interior load bearing 190 wall, the wall extends from the footing to the ceiling of the first story. That wall goes from the basement I have a problem with this question. Let me just make sure I chose the right question. So let's see. 6 meters to the second floor, and the stud wall supports the third floor. It says the stud wall and the supported under. Okay, now I get it. So we have here now. You see, sometimes it's fun playing with this thing. So here I have a 6-meter wall that goes to the first floor ceiling. It goes to the first floor ceiling. This is my basement. First floor ceiling, and then I have another floor above. That floor is supported by the stud wall. Okay, so that gives me 3 stories. Okay, so this is masonry, 6 meters, with the stud wall and 2 floors. Stud wall and 2 floors are supported on top of the 6-meter high. We have the stud wall and 2 floors. Therefore, now the stud wall supports the third floor. And the question says the wall extends from the footing to the ceiling of the first story. This is the first story, and that's the ceiling, which is the second story. Okay. It says the stud wall supporting top floor and 2 floors. The first thing we have to look at, first now it says the wall extends from the footing, first floor ceiling. The span on the supported joist is 6 meters on each side. The soil is dead sand. Then we have to check with the table 9411. 9441, and that will give us the 150, and that tells us we can use 915. Then we go to table 91534, and the question asks for the size of the strip footing. We want the depth and the width. And the span is 6 meters on either side. Now the foundation, the footing, is supporting 3 floors. So what's the minimum for the footing size? Supporting 3 floors interior. Minimum size. Raymond, the water table was within. It has to be within the width of the footing. I think it was 775, so we had to double it because the water table was 700. Warren, right, we have 500 to start, okay? But because we have the span is 6 meters, what do we have to do? Yeah, we used 915, Raymond, because the soil was more than 75. Okay, so we start with 500. That is the size with no additional. Right, so 5 times 6 over 4.9. That will give us the additional width to accommodate the increase in joist span more than 4.9. This will give us, I think, 612, maybe 612. We have 612, okay? We have 612 millimeter width. However, what else we have to add? What else do we have to add? Do we have to add anything additional to that width? Okay, and that will be how many? How many we have to add? Yep, 915, 36, 2. That's right. We got 612 plus 200. So we have 2 stories of masonry, and that is equal to 812. Now you determine the size, the depth. 812 by what? What's the depth? Right. So the answer would be A, right? So we take away the 190 and divide by 2, and we end up with 312, 311. Yeah, that would be our answer. Any questions? Hey, Melmate, nice for you to join us. Let me see if there's any other question that I missed. You guys might have gotten it all. You want me to go with any question? Question 8? Okay. I missed question 8. You guys, question 8. Ooh. Okay. So question 8, we have 10-meter long steel beam at the first floor, and it supports 3 floors of a 3-story house. It has a basement. The beam is supported at the ends by foundation walls and at the center by a 150 millimeter diameter steel column. It has a 200 by 200 by 8 millimeter bottom steel plate, and the plate sits on a 300 by 300 by 300 high concrete pedestal. The soil is from clay. As I go along, I'm picking up my little things here. So I have a steel beam with a plate, but it also has a pedestal. So this is more interest to me than the plate. And then it says I have a 10-meter long steel beam with 3 floors. Beam is supported by the ends and the center by a column. Okay, so I have a house here. The new design of the future. Everything is. Now I have a foundation wall. Wall. I have 3 floors. 1, 2, low floor. That's 3 floors. 1, 2, 3. Okay, supports 3 floors. Now it says the foundation wall is 10 meters wide, and I have a column. Okay, so I have a column. I'm going to need a footing. I have the joists on either side are 6 meter. Okay, but the column is spaced 5 meters apart. Okay, my columns are spaced 5 meters apart. My joists are 6 meters. And the column in the basement. Look at the plan. 10 meters. I have here a column in the middle here. And I have 5 meters from the foundation wall. 5 meters on the other side. And now my joist should be this way, 6 meters. Beam and column. This is my joist spacing here. 6 meters and 6, and the column spacing is 5. So where do I begin? See, so you have a picture of this? Okay. We have a picture of this, and I'm going to erase this, and we're going to start to do the calculation. Okay. Draw your plan, and then you decide that. Now, because the columns are spaced, first I have to go to table 9441 to see what part of the code I can use to determine the size of that footing. Table 9441 tells me that my soil from clay has a bearing capacity of 75. Wait, so if I have 75, it means I can use 915, but it's equal to 75. The limits on the application of 915. Then I go to table 915, 915.34, and that tells me that if I have a column supporting 3 floors, what's the minimum area I require for that column? What's the minimum area? 1. Okay, so the minimum area will be 1 square meter. However, when I go, my columns are spaced 5 meters apart, or 5 meters from the foundation wall. Therefore, that tells me I might have to do some adjustment, because when you look at the table, how do I know it's 5 meters? Because I have a 10-meter long wall, okay? And I have a column in the center. Okay? So my wall is 10 meters long. The column is in the middle. I have 5 meters on one side and 5 meters on the other side, that wall. That tells me my columns are 5 meters apart. Right? Draw the picture, Michael. Okay, so I go to 915.37. It tells me that the table is limited to spacing of 3 meters. So I have 5 meters, so I go to 915.37 bracket 1, and it tells me I have to do what? Adjust it proportionately. Okay, so that tells me I have to, on 5 meters, I have to adjust it proportionately, and 5/3, and that gives me 1.67 meters squared. Now I have area. So first I'll have to find a width. Okay, and a width, I take the square root of that, and it comes out to square root to find a width, square root of 1.67. That's equal to 1.292. 1.2.9.292. That will be millimeters. Meters, sorry. Okay, so I have a width, and then I look at 915.342, because I also saw that the supported joist span is 6 meters. That's greater than 4.9. So now I have to do another adjustment. That footing. Okay. Adjust that footing. It says I have to do what? 1292 times, that's 915.34 bracket 2, sorry. 915.34 bracket 2 says that if your span is in excess of 4.9, the supported joist length, you have to make an adjustment, and that adjustment will be, you have to adjust. So we have to multiply 1292 by 6 divided by 4.9. Again, this proportionally, we have to increase it. That gives us 158. We get 1582. Okay, and now we have the water table at 1.2. So what else we got to do? What do we have to do after this? 1582. We have the water table is less for 1.2, less than 1.5, 1.6 if you want to call it 1.6 at this point. So what we have to do, we have to double the footing. Nothing, why higher? Because why don't we have to do anything else? 1.2 times less than 1.6. Yep. So if it's less than 1.6, it means the water table is within the width of the footing. Okay. So if the water table is within, we may have to do something. But what will cause us to have to do something is the question. That is the question. 91534 bracket 3 tells us what we have to do. We have to double. Michael. You're doing well. Don't lose it, Michael. You have to read 91534 bracket 3. When you read that, are you of the same opinion? Okay, so it's clay. So what do we have to do? Double or not? Great. So we don't have to double. So we have 1582 and we have the pedestal. We take away 300. Okay, and then we divide that by 2. And we end up with 641. The answer here would be C. Okay, just step by step, one step at a time, and you get to the answer. Okay, and like I said, it's not the first thing you ran into, because here the Mincher got to 1292, 122. Some people stop, see, and then you end up with the wrong answer. If you double, you end up with another wrong answer. It depends on which you adjust first, you probably end up with a different answer. Okay? Make sure you're not doubling something twice or beyond what it's supposed to. That's why you play around with the question. Subtracting 300, get the thickness. Yes, right. The pedestal is further than the plate. Then we have to go from the pedestal. We have the pedestal here. Then we have the plate on top. How do you call? This is 300, so we have to find the overhang. We divide by 2, and that comes out to 6.41, 41 millimeters. Right? Hope you remember all this for Wednesday. Okay? So the more information you get, the easier the question is going to be. Okay? It's a guarantee. The more you get, more questions you have, For the questions, it's easier in the long run. I think we got them all, did we? Did we expect a long question like 8 on the test? No, not too many. It's just how you get. Okay? Won't be that because you only have 4 minutes, and right now I can see it'd be murder if I did that. You guys probably won't show up at the next test. But again, we'll decide that on Monday. So it could be 1 hour and whatever time it is, or 2 hours or something like that. Okay, yep, I'll go back to 31. So it could be depends on people's timing. So I would like to give you 2 hours. But, if you can't, then I 30 questions as well. Are your wish, huh? You're asking for it, Warren. How long it took us to get through 30 questions today? I know you want lots of questions. Okay, I'll give you 25. How about that? Nah, I'm going to stick to the 18 questions. Right? Don't want you to panic. Hey, there's question 31. Somebody was asking about that. What was your question here? Is Jamar? What was your question? You want 3 hours? Sure. I mean, if everybody agrees, I'll give you as many hours as you want. No, so I give you as many hours as you need. Okay, but they'll be related to the question. Exactly. We 3 hours. That was let's see, 180 minutes. 1.0 divided by 31. 5.8. So that's not bad because I'm giving you at least 5.5 minutes. Today we spent 5.8 minutes. So in 120 divided by 18,